Hi, and welcome to the third entry in our series on geospatial business intelligence in industries. We hope you've had a chance to look at the first two, geospatial BI for insurance and geospatial BI for oil and gas. But today we're going to look at geospatial business intelligence for utilities, and in particular, we're going to focus on geospatial business intelligence for smarter water management. Now, when you think about GIS in the utilities industry, it's no surprise that it's a huge play there. Every utility has to deliver something from somewhere to a huge market, to potentially hundreds of thousands or millions of people. So they're delivering things across networks to consumers, to organizations, to other businesses. So there's a whole physical infrastructure management process that has to happen there. In addition, when you think about utilities, whether it's electrical or water or telecommunications, there's also situational awareness. These organizations have to know when there's an outage. They have to know when there's a spill. They have to know when there's a flood. They have to know when there's a transformer down, because it costs them money when things go down, and it creates havoc for customers. There's also the idea of location and routing. How do we route our utility delivery systems, whether it's transmission lines or water mains? All that stuff can be handled best visually with a map and GIS and all that rich GIS data. And of course, then there's all the operational management and planning that comes with everything in terms of work orders and fixing events, those kinds of things. Today we are going to focus on water management. Now, water is a dwindling resource, we all know that, so the emphasis has never been more on managing it in an intelligent way. So what are the things that you can gain from geospatial BI for water management? Well, there's a lot of instrumentation out there for water management. You can see at a glance and analyze your infrastructure, the age of your infrastructure. You can predict things like where are we most likely to have to do repairs, how much are those repairs likely to cost given where they're located. And if you can tie that into business intelligence data, historical data, for example, about how much historically things have cost, like traffic rerouting costs or additional policing costs, whatever, you can get a real picture of what you're likely to have to spend in the upcoming year. So that's the analysis of the ancillary costs. There's also the potential analysis of new initiatives like smart metering. How well is it working? You could even think of scenarios where you could expose the reports geospatially, where somebody could go into their neighborhood and actually view their own consumption of water via the meter, and see where and when and how they're consuming water. Of course, there are lots of other areas in smarter water that we're not going to cover today. There's a whole idea of who are we selling it to? What are the demographics of the people who are consuming water? As taxpayers or as consumers, who's consuming the most water? What can we do to up our conservation efforts in those areas? So let's take a look at geospatial BI with Esri maps combined with IBM Cognos Business Intelligence. Here I am in a water manager's dashboard, where you can see I've got some interesting stats on traffic rerouting costs and whatnot up on the left, and I have a map over here on the right. If I scroll down a little bit, you'll see that I have a list of zip codes with some interesting stats on units and repair costs and lifespans and things like that. Now, if I actually move in over the map here and I hover over an area, I get some statistics popping up based on that area. But what am I actually looking at? These regions are thematically shaded. If I open up the legend here, I can see that I'm actually looking at an estimate of the years overdue, the average years overdue for maintenance that the equipment in these various zip code regions are in New York City. These are displayed in equal interval segments, and I can easily change that to be segmented in quantiles. Just going to move the legend over to the left here a little bit. You can see that it's multi-measure in nature, and rather than looking at years overdue, I can also look at things like the average cost of repairs in any region. And I can see here in this zip code 10019, they're quite high, as they are in zip 10016, and maybe slightly less so in 10022. I can likewise switch and view the average lifespan for any given region that I manage here and see how long equipment tends to last. But for now, I'm going to go back to that years overdue measure. And very quickly, from the toolbar here, I'm going to select a tool that's going to allow me to draw a line between these two red shaded regions here to update my report and tell me which two of the regions that I manage have the highest number of years overdue in terms of maintenance schedule. And looking at the numbers here, I can see that there's nothing really hugely overdue in this region and the top of the crosstab here. They're all fairly low numbers, and in fact for my system valves it looks like I'm way ahead of schedule. Unlike in this other region where I have an 8-year overdue for my hydrants. Now I'm going to change the selection over here on the map to these top two, because you recall that the repair costs in the upper left one were quite high, so I want to see the combination of these two. And again my report updates, and I can see right away that in both of these regions I've got maintenance overdue on hydrants in both of them, and possibly maybe even intersecting. They are adjacent regions after all. Now right in my dashboard here I have access to a couple of other reports, and I'm going to run this aging infrastructure by type report. Now what this brings back is a map that has all of my equipment. I want to classify it by age and by type. Remember, we're interested in fire hydrants here, so I'm going to find all of the 60-year-old fire hydrants in this region. And you can see there are quite a few in the area we were interested up in the north. If I hover over any of them, I can get the information about them. And as I can with any Esri map, I can zoom in on a specific location. So there are the fire hydrants I have to worry about. Now if I want to find out specifically what costs might be involved in repairing these, I can select this polygon tool and then very quickly and easily draw an irregularly shaped polygon around a specific set of these. So for example, if I were dispatching a work crew, over a period of a week or 2 weeks to execute a work order against these, I can very quickly see what the repair cost might be for them. Now I'm going to go back to my main report because I have access also to my smart meter water pilot project here, which is going to launch another report. And this is a report that shows smart meters versus meters that are not in a specific area where we've implemented a pilot project. So it's got a chart here and a table that shows the average usage, and I can see that actually consumption for people using smart water meters is down, even though the price is higher. The price for water based on smart meters is slightly higher. On average, constituents here are saving money. Now, suppose my boss comes to me and says, I would like to, I've got some complaining constituents and I want to see what the numbers are bounded by specific streets. Say, east of Park Avenue between, that looks like 53rd and 57th Street. I can do that very quickly and easily. I can just run this report. Once again, my report will update and I will see exactly what the trend is. So again, you can see the constituents are actually saving money, $115 versus $110 per unit in this region. If somebody else wants the same kind of numbers for a different region, just west of Park Avenue for a slightly different shaped region, I can rerun the report. I can start providing these numbers to show the success or failure of my smart water program to anybody who's interested. So there you have a fairly straightforward example of how IBM Cognos Business Intelligence coupled with Esri ArcGIS servers and map services can really add value in terms of managing utilities, in this case water, but it doesn't necessarily have to be water. The key use cases you saw here and many others extend to managing electrical grids, delivery of electricity, again the service and operations component of electricity. In fact, extending out to the marketing and sales of said electricity or oil and gas through pipelines or whatever utility it is you have in telecommunications, for example. Where's my service coverage and who am I covering? By combining things like demographics in areas, you can understand who you're trying to sell to and target your campaigns effectively to those people. So admittedly, yes, the demo was fairly straightforward and kept simple for understanding's sake. It's barely just bits touching the surface of what's possible when you combine Esri ArcGIS services, map services with IBM Cognos Business Intelligence using spot-on Vantage maps. So if any of you out there have utilities or are members of utilities organizations that really need to bring together some of your financial data, for example, of IBM Cognos, or forecasting data, planning data, and visually analyze that data together with your infrastructure for your utilities delivery, give us a shout at Spot On. Go to www.spotonsystems.com/utilities, and we'll get back to you if you take a few minutes and tell us a little bit about yourselves on the form that's provided there. Thanks for taking the time to learn about Spot On Vantage Maps and smarter water management.